So my presentation will be about the latest interface development that we've done in the context of, as I mentioned yesterday in my presentation about investment casting, it's in the context of facilitating the management of material data. So this presentation was done with the help of my colleague and boss, Frédéric Coste. So this is an ongoing work since early 2016, okay? And we are continuously improving this development, so we might have some changes in the near future. So I will be presenting the viewer and editor interface and the new unit management in terms of system of units. Then I will finish with the microstructural properties and the more heavy models in terms of segregation and grain structure. Okay, so the tool is called Material Data Tool. Okay, so it's a rather simple tool in which we are going to be able to create a material from scratch, or we import an existing material. Now, for those who already use THERCAST, you know that we have a database of existing material files, so we are going to be able to import from these files. Then we have a window for specifying the units, the system of units, okay? The input of nominal composition. Now, what is interesting about this interface is that since in THERCAST we had a continuous need of defining a nominal composition, for example, in macroscopic properties or for segregation. So the added value of such interface is that all common properties are centralized here. So next to the nominal composition, we also have some kind of help for users. So you can define the alloy family. So I'm not sure if it's visible. So here we can read user defined, or we can specify steel or copper alloy or whatever. Then here we have, okay, a more specific window, which is the Boussinesq approximation. I won't be speaking about this today. But just to say that, also we have this help for users, which is the comments window. If you ever want to put your comments down here, they will be also saved within the material file. Then finally here we have the specific export and saving options. So to input the alloy, let me just go back once. Either we can choose the family and input our nominal composition, or it's possible to use the user-defined mode and then go and click on the periodic table, which is right here, okay? And this may come in handy if you want to define an alloy which does not exist in the predefined alloys. Okay. So, the latest addition to this tool was the macroscopic properties and microstructural properties. So macroscopic properties is simply the interfacing of the already existing material properties that we already have in THERCAST, which is like thermal conductivity, density, and so on. And then later on, I will speak about microstructural properties. So the idea of this tool is to be able to modify our data without having to go into the files and change the files, and maybe without inducing any errors within the files. So this is not just any interface, it's an interface we are going to do background checks and checkups to make sure that everything is okay. Okay, so before I was in the alloy property section, now I'm in the macroscopic property section. And here we can see just under the macroscopic property section, we have, I will maybe step aside, we have the thermal conductivity, specific heat density, and so on. So all of these properties were existing in the material file that I have imported. So right here we have the plot of this, now here I'm in the thermal conductivity. We have the plot, and we have the data points that were plotted. Now what is interesting is that In this example of material file, I have already set the system of units to meter Pascal, so which is the SI system. And so here we can see on the field that we have a tabulation of thermal conductivity as function of temperature, and we have the unit for temperature and the conductivity. Now, I will show you later how it will be able to change the unit of every field within this material file. So this is what I already showed. Okay. The next handy addition to this tool is the ability to import field by field, which means, let's say we have an already existing field, which is the thermal conductivity here, and say I have a new tabulation of thermal conductivity. I can click on the import data from file here, okay? And then I will be able to import my new data points. Then we have the possibility to click on the reset if you ever have any, if you ever made some errors regarding this, this field or any field later on. And then we have the insert and remove point, which I will show now. So before continuing, so what I've shown is that we may have for every field a tabulation, but we may have also a model. So for example, in THERCAST, and for those who already use THERCAST, we have implemented an analytical model for the viscoplastic model consistency. And so such model may be the parameters of such model may be entered by an interface like this. And so the added value of the interface is to be able to see the values that this model generates, okay? And not just go to the solver and launch a simulation and then see how the viscoplastic consistency is calculated. So, among the features, as I said, we can add points, we can remove points. So this is an example where I'm adding a point, removing a point. This is a rather simple and fast task. As I said before, we can also import the data file. So this is an example of importing a data file. So here I have an example file, which is test.csv. So we are going to be able to import CSV files and TXT files. Now, for those who do not love frustration, we can import CSV with semicolons and commas. So this may come in handy sometimes. The next interesting thing is that we are able also to import multi-column files. So and everything is done automatically. So if the file consists of more than 2 columns, you will be asked to choose which columns to import. And this may be, it may facilitate the work sometimes. So in this example, I had 4 columns and I chose the temperature column to be the first one and then the EVP consistency to be the last one. And once you hit on import, you have this plot right away. If you have already existing files with comments and with text within them, it will be possible to ignore these lines, so you don't have to modify yourselves these files. So everything that comes in text or in comment symbols will be ignored. And it's also possible to import files having only 1 column, in which case you will have a automatic X coordinate of 0. Okay, so as I said before, after modifying anything within the interface, adding, removing, or importing a data, we can always go back and reset the data if we think that we have made any errors. Also, on the anti-frustration options, we may also export our data that were entered through the interface into an Excel format. So in this example, I've just shown a part of these exported fields. So each field will be exported into a single sheet. And here, for example, I'm showing also the thermal conductivity. And so if we have set a unit before exporting, it will be possible to see the unit that was used in the original material file. Also, on the exporting options, we have the possibility to export all the plots into a PDF file, which may also come in handy if you want to write some report or any kind of report about the material file. The next very important feature in this interface is the management of units. So up until now, we always in THERCAST had several groups of material files, each one for a single system of units. And so the added value of this new interface is to be able, through one material file, to manage all the system of units. So what I'm showing here is, again, on the thermal conductivity property. I'm beginning here with the SI system. So I have I think, watts per meters per Kelvin. Okay, and I have this temperature in Celsius. And say I want to go and work in a US system of units. So what I've done here is click on the combo that lets me choose the unit. And here we can take sneak peek on the available units. Then in another step, in the next step, I'm also doing the same thing with the temperature unit. Now, of course, it may be difficult to do this for every given field, for every tabulated field. So we also think of our clients, and this is why we have the global system of units. So if you change the global system of units, these tasks will be automatically done for every single field which exists in the material, in the interface. Now, what should be noted also is, let's say we already have a material file, which is in the SI system, for example. By clicking, let's say in this example, the inch PSI USC system of units, all the data that exists within the interface will be automatically converted. So you don't have to do anything else. Okay, next is the microstructural properties. So this is maybe the most recent work that we have done, very close to segregation users. So microstructural properties are basically the calculation of dendrite arm spacings. So what we have done actually is open for the users the possibility to compute the primary and secondary dendrite arm spacings. Now this may be only relevant if you are doing segregation calculations, because these dendrite arm spacings are only relevant to the computation of the mushy zone permeability. So in this example, I'm showing the secondary dendrite arm spacing. Maybe it's worthy to mention that until the most previous version of THERCAST, we only had constant secondary dendrite arm spacing. So now the addition is that we have models to calculate this dendrite arm spacing. So here we have preloaded models. And when we have a preloaded model, we have the preloaded, of course, values of this model. If you wish to use your own model with your own values, you can always use users SDAS model or PDAS if you are using the PDAS calculation. And next to it, what's very interesting also is that we can see what are the values that will be fed to the solver after importing this material file. So here we have the plot and we have the data points. So of course this is available for both PDAS and SDAS. Now, assuming we have chosen a computation mode for either PDAS or SDAS, we can come here and choose a specific analytical model for the permeability of the mushy zone. And again, this is only relevant for segregation. So in this example, we have 3 models, one which is PDAS dependent, another one which is SDAS dependent, and we have the last one, Poirier, which depends on both PDAS and SDAS. And next to it, again, we have the data points and the plot that will be used by the solver. So, as I said, in this interface, we are trying to let the users, let's say, use less Excel to visualize their data. So in this sense, it's going to facilitate the workflow and let you be less frustrated, I assume. And finally, for the Heavyworks, so this section is for the setup of simulation, of segregation and grain structure. So first of all, I will start with the latest additions that were done on the parameters of segregation. So what we are presenting here is the segregation tab. Okay, so we had the microstructural tab, macroscopic properties, and this is the segregation tab. So if you enable microsegregation, you are able to choose among 4 options for the solidification path. Now, among these options, we have 3 analytical models, which are the lever rule, Scheil, and the Brodly-Fleming's model. So using these analytical models, we will assume that it's only limited for now for binary alloys. However, there are 2 exceptions. If you are using steels, we may have an approximations, which we call the pseudo-binary phase diagram. So in this example, I'm taking a steel and I'm applying the Scheil model into this alloy, okay, which is a iron, carbon, manganese, nickel, and chromium. So here we cannot see the nominal composition because it was defined in the other tab. But anyway, here we have for each couple of solvent and solute the linear phase diagram properties. So using these properties, we can compute a multi-component solid fraction and segregation properties. And here on this last column, we have the diffusion coefficient that will be used for every chemical species in the macrosegregation computation. Now, as I said, this multi-component analytical approximation is made only for only for steels. If you wish to go beyond steels, there's always the possibility to go and work with a thermodynamic database. And so in this example, we have, I'm showing actually an external data file that was generated by an external tool, which is developed at CIMEF. I'm not really sure if it was mentioned before? Okay. So this is called the Physiology Library. It is developed independently by the CIMEF lab. And basically what it does is compute equilibrium using thermocalc as a backend. But anyway, so I have used this library to generate a file. In this file, I have the full equilibrium computation for a list of temperatures and a list of possible nominal composition values. And so using this, I can do a more accurate segregation computation because it's not based only on analytical models. And again, we have the diffusion coefficient because this is for macrosegregation. Okay, and finally, we have the microstructure or the grain structure tab. So this is only a retrocompatible window. So for those who have already used THERCAST in the past and enabled a CAFE model, this is basically the same input. So we have the nucleation parameters, surface and volume. We may have added a new feature, actually, is the custom surface and custom volume nucleation. So for those who need to do maybe more specific nucleation scenarios, you can click on custom volume nucleation and define a specific coordinate for your nuclei. This may come in handy sometimes. So otherwise, you can keep with the default parameters, which are here. Sorry, not the default parameters, but the default window, okay? And then you can define the growth model for your microstructure. Okay, for the conclusion, so this is, for us, this is a crucial step in a better use of THERCAST and better use of simulation setup. It's the first step to centralize, as I said, all input points from properties to advanced features such as segregation and grain structure. As a future perspective, we are still studying the possibility of linking directly this interface with one of the existing or maybe all the existing thermodynamic software such as Thermocalc and GMAT-Pro. But this is not something that we are sure to do. We are still studying this possibility. Thank you.
Yeah, the enlarged possibility to include data from CalFAT, yeah, that's a good idea. So you mentioned Thermocalc and GMAT-Pro, but have you also maybe in mind other library that could be linked?
There are lots of CalFAT-based software now, but maybe it's more interesting for the present time to focus on Thermocalc and GMAT-Pro, because simply Thermocalc is already used among many users now. Many of our clients and even non-clients who work in this domain, they already have Thermocalc licenses. And for those people who do not work specifically with thermodynamic things like, let's say, segregation, they might use GMAT-Pro. So I think it might be more useful to focus on these two, but if we do this sort of coupling, it may be easy to go further and try, for example, Pandat or other stuff. There are lots of packages now.
Okay, good. Okay, thank you, Ali. So yes, once again, this really gets you easier the setting of the material data file, because I know that we receive a lot of questions about this. What you need, what are the uses of this parameter. So here with this interface, this is really clearer and easier to do the setup, even in very complicated modeling like the segregation models and so on. So once again, thank you, Ali.
Thank you.